Good everyone, my name is Graphics. Now, if you look at the front of the screen, there's a question on binomial expansion that is displayed there, and the question goes like this. It says 3x minus 2y squared all to the power of 3. We should expand that using binomial theorem. So from here, what you do is you take 3x and minus 2y squared, you take them into section, right? So the first one we have 3x and minus 2y squared, that is one section, plus 3x minus 2y squared, 2 section, 3x minus 2y squared, 3 section, 3x minus 2y squared, another 4 section, right? So the reason why I'm taking it up to 4 is that the power is 3. If the power is 4, you do it like this in 5 places. The power is 5, you do it like this in 6 places. If it is 6, you do it like this in 7 places. So we are doing it in 4 places because of what? The power is 3. Now the next thing you do is, starting from the first value here, which is 3x, you put the highest power, which is what? 3. So if the highest power here is 3, then the next 3s will have 2, then the next 3s will have 1, then the next 3s will have what? 0. So it is descending from 3 to 0. Then the second one will be ascending. It will now be what? From 0 to 3. So I'll be having minus 2y squared raised to power what? 0. The next one will be minus 2y squared raised to power 1. This one will be minus 2y squared raised to power 2. And the next one will be minus 2y raised to power what? 3. So that is the next step you do. Now, recall in mathematics, especially in your indices, we say a m to the power of n will give us a to the power of n times m to the power of what? N, right? So if I implement it here, I will now be having 3 to the power of 3, x to the power of 3, right, in one bracket. Then since this minus 2y squared to the power of 0, n to the power of 0 is what? 1. So I put 1 close to it. Now if you look at, we have 3x squared in brackets, 3x in bracket all squared, multiplied by minus 2y squared in bracket all is power what? 1. Now there's something I wanted to know here. Whenever you have a base and the base is negative, but the power is odd number, your negative will always remain. What I mean is this: if I have minus 2 raised power 1, no matter what, I will still have minus 2. If I have minus 2 raised power 3, we'll be having minus what? Minus 8, because it will be minus 2 times minus 2 times minus 2. So we'll be having minus 8. If I have minus 2 raised power 7, I will still have what? Negative still involved in the value there. So any odd number, the negative will still remain. So since that minus 2y squared has 1 as the power, what will happen? The negative will still remain. So negative will affect the positive in front of the 3x squared. So it will be minus times plus, will have what? Minus. So we'll now be having 3 squared x squared in brackets, then 2 and what? Y squared. So this is what we're having. So to the next one. Now similarly, we are having 3x all to the power of 1 minus 2y squared all to the power of what? 2. That is minus 2y squared in bracket all to the power of what? 2. Now whenever you have any base that the power is even, the negative, and if the base have a negative, the negative will disappear. Now if I have minus y minus 2 raised to power 2 to give us 4, minus 2 raised to power 6 will give us 64, minus 2 raised to power 4 will give us 16. So as long as the power, as long as it is even, the negative will disappear. So we'll now be having 3x to the power of 1 will give us 3x. We'll be having 2 to the power of 2 and y to the power of 2 times 2 because of the power there. That's taken. Now to the next one, we have 3x to the power of 0 multiplied by minus 2y squared to the power of what? 3. Now you need to understand that since the minus 2y squared has an odd power, so the minus will still remain. So the minus will affect the plus in front of the 3x to the power of 0, and that will give us minus times will give us what? Minus. So we have minus 3x to the power of 0 is 1, so we have minus 1 in brackets 2 to the power of 3 and y to the power of what? 2 times 3, right? So we're applying the law of indices, and that's what we have. Now from here, we know very well that 3 to the power of 3 is 27. So the S3 still remains. And 27 S3 times what give you what? 27 X3, right? Minus 3 to the power of 2 is 9. 9 times 2 is what? Is 18. So we're having 18x squared, y squared. Plus 3 multiplied by 2 squared. 2 squared is 4. 4 times 3 is what? 12. So we're having 12x y4, y to the power of 4, minus 2 to the power of 3 is 8. So we're having 8 y to the power of 2 times 3 is 6. So 8y6. So this is what we're having there when you expand that. But there's still one more thing that's remaining, and that is what? The coefficients. We've not yet inputted the coefficient. So for you to input the coefficient here, you need to involve your what? Your Pascal triangle. Now when you have Pascal triangle, what you just do, you are going to draw a triangle like this. You draw a triangle and you divide it into, since you have a power of 3, divide into 3 equal parts. But I'll just take it into like 5 equal parts, right? So the first one, if you have 1 plus 1, you'll be having 2. That is to the power of 2. The next one will be what I mean here is this. You draw a triangle, right, and you divide it into as many equal parts as you can divide it, and you take the first, the last, the first, the last, the first, the last, the first, the last, and what? The first, the last, right? So in doing that, this times this plus this will give us what? 2. This plus this will give us what? 3. 2 plus 1 is what? 3. So from here, if you look at one that has 3 in a triangle, which is along the row, we have 1 3 3 1. You now write that the coefficient of expansion is 1 3 3 1, right? Now if you are multiplying the coefficient of expansion with what we expanded above, the first one is 1 times the first expansion there is 1 times 27x cubed, we have 27x cubed, minus 3 times 18x squared y squared will give you 54x squared y squared, plus 3 times 12x y4 will give you 36x y4, minus 1 times 8y raised power 6 will give you 8y raised power 6. So this is the expansion that we have. So if you found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.